welcome. This is breakout number 3, focusing on the FathomNet models. To start, I'm going to walk through some of the models that we have available on Hugging Face right now. And then I'm going to transition into a Python notebook that we put together that walks through how you can actually pull down the models, pull some data from the FathomNet database to actually validate them against, so you can see how the performance is. And then also, hopefully you all saw the note to bring images or video if you have it, and then you can actually upload that into the notebook environment and run the model on it to see how it performs. So that's what we're going to do in the next 40 or so minutes here. There's a link that I'll send you guys here to follow along. So the first thing is we're going to walk through some of the FathomNet models. So this is a link to our Hugging Face organization. This is where we land all of the actual FathomNet models and also have some interactive spaces to interact with the models with. All right, so I'm hoping you all can see that screen there. So when you load up this website, you'll be brought to this page. There's a little bit of information about what we've previously been calling the FathomNet Model Zoo. Again, right, this is a resource for us to be able to make use of the data that we have in the FathomNet database. We're going to be training machine learning models on it, and we have been, and then folks in the community also have been contributing models. But the idea here is that, right, as we are making use of these data and folks like you who are training these machine learning models and making use of them, hopefully they don't just serve one purpose and then go away, right? The goal of the FathomNet models is that folks in the community can contribute them back and have this shared resource. And then hopefully describe a little bit about the models, how they were trained, what the intended use cases are, so that people can use this as a resource in case they have a similar task and they want to see if there's a pre-trained model available to tackle it. So a couple of components that I'll walk through here. I'll actually do this in reverse order. So I'll make the screen a little bit bigger in case it's hard to see. At the very bottom, you have the listing of models. Like I said, we have 10 models that are currently available on this Hugging Face organization. And these are all sorts of different use cases. You can see some of them described here. If you click on one in particular, I'll do this megalodon one, which will be a sort of focal model for this breakout. You can see some information about what the model is, how it was trained, the architecture, the tasks that it's suited to. So in particular, right, this model is focusing on a single class object detection, right? So just show me the things in this image that are relevant, right, and salient. And this is a model that's trained using all of the localizations that we have in the FathomNet database. So some information about the intended use, factors involved in its training and deployment, and then also a little bit about how you can actually deploy this for yourself. And we'll step through that in more detail in a second here. If you want to actually see the files, right, you'll have to click on this tab here. So if you go to Files and Versions, you can find the actual model weights here, as well as some plots showing for example, the F1 confidence curve on the validation data from the training. There's also if you're familiar with TF records, then we can visualize that in this interface. Yeah, yesterday I had the same issue where it's only taking up half the screen. I'm not sure why, but you can see some information about the training and how that was conducted if you're interested in seeing the model at that level of granularity. And the last thing I want to call out that we have for each one of the models is this community tab. This is very similar to GitHub issues, where you can just open new discussions, or if you want to change things, you can also open pull requests. I will say that if you want to join this community, you can do so. There's some instructions here. First you will have to sign in or sign up, and then you can press this button, request to join this organization. That'll just send a request to us, we'll approve you, and then from there you can submit models and interact more deeply in this interface. All right, so that was in brief, the actual models that we have available here. The next thing that's pretty awesome that this platform allows us to do is to host these interactive, what they call spaces, or these demos for the different models, so that if you want to actually try out one of the models on your own images before, investing more time and effort into spinning it up for whatever you need it to do, you can just click on one of these spaces. So this will pull up an interface. This is a Gradio interface, and what you can do is just upload an image, right, and then hit submit, and then it will run somewhat slowly. This is running on a CPU, I believe, but it'll tell you what's there. And we have some example images too, just to get a feel for how each model is performing. So you can click through these and just kind of get an idea. Again, this model in particular, the megalodon detector, um, is very similar to the mega detector in the terrestrial scene, but this is trained on all of the FathomNet database bounding boxes. So that's the spaces in brief. I encourage you to play around with all of these and see if there's anything that fits your needs. And last but not least, I want to shout out the fact that as part of the FathomNet team, we are working to curate this collection of 4 different baseline models. And these are intended to be retrained periodically on frozen sort of snapshots, benchmark sort of versions of the FathomNet database that serve 4 different use cases. The first one being the megalodon, again, just trying to be a single class object detector. To help us, without doing any classification, to find things in a scene. So again, you can find the model there and then try out the space. The next one that I do want to shout out, and Kakani mentioned it before, is the vulnerable marine ecosystems model. And again, this is targeting those VME indicator taxa. In particular, I think it has just a few classes. Yeah, coral crinoid fish was included, not as a VME indicator, but as a you know, typically a class that you see at the same in the same frames in VMEs, and just to help the detector distinguish that, and then also sponges. The last 2 that we're in the process of training are a midwater and a benthic supercategory detector. So putting a little bit more classification effort into a very high level detector, so that we'll be able to have some large groups of sort of morphotaxonomic um, uh, classes, and then we will train a model on that, again, using the FathomNet database data. All right. Can the models be used with own data for fine-tuning? Yes, absolutely. Most of these models are YOLO models, and I think the latest ones that we have in here are YOLO V8 models, and the Ultralytics package has a lot of support for plugging in your own data, taking existing models as a starting point, and then retraining or fine-tuning that classification head. Okay, sweet. I'll pause for a second. Anybody have questions at this point about FathomNet models? All right. YOLO V8 is the best version of YOLO for marine image classification. Certainly not, right? I think the YOLO models are pretty easy to get going with, and that's one of the reasons why we've targeted those. They're also fairly performant, right? That's the selling point for the YOLO models, is that you can deploy them on lower end hardware, and they're quite speedy for inference. But there are definitely better image classification architectures out there for image classification. Are the training and evaluation pipelines available? This is something that has been a sticking point for us. No, not currently, but Laura is who's leading one of the other breakout groups, is our MLOps research engineer, and she is working to basically rewrite these training and evaluation pipelines and Dockerize them, and then publish them. So that you'll have sort of full transparency around what training data went into the training of these baseline models, and then also how we can evaluate them, right? All right. Perfect. Okay, so again, in brief, that was the FathomNet models, and how you could find them again is either through the FathomNet database website, they're linked there, and that'll bring you to this page, huggingface.co/FathomNet. I really hope that you all will, join the organization, and maybe, as a result of this session, if you're playing around with some of these models, leave a comment or a discussion post around, what was working well for you, what did you expect to work, what failed, and anything like that, because we're keen to understand sort of where these models are performing well, and what distributions that they're still struggling on, especially as we're seeking to grow the size of the FathomNet database. Understanding the distributions that are not, well fit yet is important for us as we're sort of prioritizing how we're growing that data set. All right. Awesome. Okay, so that was that. Next part of this breakout is, like I said, I have put together this notebook for us to be able to run. This is linked from the FathomNet Pi repository, but I'll send the link here. Just want to show you this in case you wanted to find this notebook again. At the bottom here, we have a couple of examples on using FathomNet in Python. And this is the new one, the FathomNet models. So this link here, I will paste in the chat. My hope is that you all will be able to follow along, and especially if you have your own data that you want to test with, then this is a great opportunity to be able to actually download the model, see how you can run through that process. We're going to be stepping through some of the code, but again, if you're not into Python, or you don't have experience there, then all you have to do is press the different buttons and step through this in order to run it, and you don't have to tune anything. But this is the notebook here. So I'll make it larger too so folks can see. And yeah, so what we're going to be doing is we're going to do sort of three things. We're going to show how you can download the different FathomNet models from Hugging Face into this notebook environment, how you can actually evaluate them using the Ultralytics package, and then also how you can run inference on your own images or video using whatever model that you're so interested in. We're going to be focusing on those YOLO V8 models for reference as well. But again, link here to the FathomNet models and the FathomNet database. I will say one sort of administrative note is I would recommend that if you are running this, make sure that the runtime is selected as at least the T4 GPU. This will make sure that you're not trying to run the model on a CPU, which will take quite a while. Yeah, so you can do that by clicking here and changing the runtime type. You can also click runtime and do it from there. But I'll say that this environment, right, this isn't running on your computer. This is running on some hosted instance with a GPU on it. So you can try these models in an environment that can actually run them pretty well. All right, so first thing that we'll do, I probably should have run this before I started talking away, but we're going to have to install some packages. To note, we're going to be installing the FathomNet Pi package, and this is just to facilitate pulling some data from FathomNet for us to validate against. There's another package from Hugging Face in particular that will facilitate downloading the models in pretty easy to parse way. And then the last one is Ultralytics. This is the YOLO architecture package. This helps to run the actual models and do tasks like validation, and is a focus point for a lot of this notebook. The last two I wouldn't worry about. They're just a little extra dependencies that need to be pulled in. So this will run. Hopefully it won't take too long. As this is going, anybody have questions? All right. We'll give this a second to finish up here. I'll talk about a little bit about this next section as that's finishing up. So right, like I just showed you, we have these 10 models that are currently available. A few of them are YOLO V8, which we're going to focus on now. And we're going to consider the Megalodon model. So again, single class object detector. We're also going to look at the trash detector. So this is one that was specifically trained to detect trash in the ocean. And then also the YOLO V8 version of the MBARI 315K model, which is it's a YOLO V8 model that we trained on 315,000 annotations, both from the FathomNet database, but then also internally at MBARI, some of that data. What is the difference between FathomNet / MBARI 315K YOLO V8 and MBARI 315K YOLO V8? Different data sets, or is it just to deal with paths? Margot, could you clarify where you're seeing that difference? I'm not sure.
It's in one of the cells for model options.
Okay. Sorry, so is it this one here?
Yes.
Yeah, so this is just a quick thing that specifies, for these different models, what's the name of the repository on Hugging Face, where that model lives, and then what's the particular file that we need to load from that repository. So going back here, on the 315K YOLO V8, just for reference, if we, let's see here, I'll back us up. If we go down, oh, it didn't work. FathomNet. Here we go. So if we go to that model, right, the name of the repository is FathomNet / MBARI 315K YOLO V8. But then if we go to the files and versions, we can see that the actual weights that we're interested in using from this model are named as such. Okay, so hopefully this is done by now. Okay, fantastic. So yeah, the first thing we'll do is download one of these models. So if you run this cell, this should create a little drop down for you to select. We'll start with the Megalodon model. This is what we're going to use for the validation, the sort of evaluation stage of this notebook. But if you want to try out some of these different models for the inference later on, all you have to do is basically select a different one and then run this download weights cell. So we'll run this, right? This is going to use that repository name and then also that file name, and it's going to pull it into our environment here. You'll see that after running that, we downloaded the model to this particular location. And if you want to see, where that file actually landed, you can go all the way down here, and there's the weights file that we're going to be pulling in to run inference with. All right. The next thing that we're going to do in this notebook is we're going to try to evaluate it, right? So now that we have this model, right? One question we might want to ask is, how is this going to work on my data, right? And do I have some particular animal that I'm looking for, right? Is this single class detector even going to pick up on the thing that I'm looking for, right? So this is a pretty basic cell that's just going to pick one sort of concept in particular. You can try changing this if you want. This is just one that has a somewhat small set of images in it to download, so it's quick to run here, but you can try changing this out. And this is going to, first sort of summarize using the FathomNet Py utilities how many annotations we have of that. And then it's going to actually generate a YOLO formatted data set just directly using the FathomNet database, FathomNet generate command using our particular concept. And it's going to download the images and the annotations into this environment. So I'll click this. It'll tell us, we have 152 bounding boxes of microcoma in the FathomNet database. And this is going to fetch those images right now. That'll take probably about a minute. But what this is doing is sort of creating this data set here where we have the images all saved here, right? And we can open them up and see what they look like. Okay, and then we also have the labels that are being saved as well, which describe the actual bounding box and the class. So this is just, microcoma is the class, and then these are the bounding box coordinates. I'll note that this utility can also be used to generate training data sets from the FathomNet database. If you want to do it that way, you can export into Pascal VOC, Coco, or YOLO. And then it'll generate this sort of data set YAML file that describes what you just downloaded. All right, so it's still cooking. All right, perfect. So now that we have this this data set here, right? What we're interested in doing is taking our model that we just downloaded and then running inference on all the videos, right? Or sorry, on all of the images. And we'll compare, right? What are the actual ground truth annotations that we just pulled from the FathomNet database, right? Expertly annotated bounding boxes. And then we will take the Megalodon model's predictions and compare them against what the human annotator said. And then we'll use the sort of discrepancies in order to compute some metrics that will help us to understand the performance on these data. Okay, is there a way to pull out data sets from the FathomNet database with certain geographic bounds? Yes, absolutely. I'll jump real quickly. So FathomNet read the docs. So this is the documentation page for the FathomNet Pi utility. And in that script, FathomNet generate, there's a few instructions here on how to use that and to pull data. But there are a number of ways that you can constrain this data set generation. You can say, you know, I want specifically from this contributor, start and end date times. If you want to constrain it, you know, by time, imaging types. So for example, ROV imagery, you can select whether or not you want to include or exclude verified and unverified data. You can specify here a sort of a geographic bound in terms of minimum and maximum lat and long, and then also a depth band. And then also, you can filter by different institutions. I hope that helped. Okay. So coming back to our notebook, right? We've just downloaded this data set. Now let's actually evaluate it, right? So like I said, we're going to be using this Ultralytics package. We're going to import the YOLO model, and then we are going to instantiate the YOLO model on the weights that we just downloaded, right? From there, we're going to call this val function, giving it the path to our data set that we just downloaded. So I'll click this button. This will, load that model. All right. And then it's going to scan all of the images. We have 68 images in our little data set. And now it's going to actually run the inference against them. And once it's done, it'll report some of the metrics. So we'll see, this is wrapping up, right? We had 68 images that we ran against. There were 152 bounding boxes as we expected. The precision was 75%, recall 87%, mean average precision at 50%. Was 0.837, and from 50% 95% was 0.5. Right, so this gives us some summary statistics about this run. Okay. Oh, I see, Jack, you have a question about depth and location data linked to annotations. How do you format annotations to include that data if you share it to FathomNet? It's a good question. So that I would definitely recommend watching the recording from Brian and Laura's breakout session. They're walking through right now exactly how you can format that data. It's short answer is you create a CSV where each annotation has a different row, and then in that you can specify the latitude and the longitude of your imagery. And we also have a documentation on how to do that in our blog. So if you go to medium.com/FathomNet. This first one that's here, how to submit localized image annotations to FathomNet, walks you through exactly how to format that CSV. Yeah, thanks for the link, Izzy. Sorry, I should probably just be pasting these links in the chat.
That's all good. I got you. There's another question before that, Kevin.
Oh, yeah. I think I covered Isaac's, unless I'm missing another one, Izzy.
Okay.
Okay, great. All right. So, coming back to the notebook here, right? We just ran this validation, right? And this computed out a bunch of metrics for us that we're interested in. But let's actually see if we can visualize some of these metrics. What we're going to do is actually open up what we just generated. So if you see in this Microcoma data set, we have a new directory called runs. This is the first validation run that we ran. And then some of the outputs that we actually generated here are these different curves. So an F1 curve, a precision recall curve, precision curve, recall curve, confusion matrices, and then some of the example sort of ground truth labels versus what the model predicted. This cell will just sort of plot these all together so you can get a sense of how this is performing. I'll minimize this so it's a little bit easier to see. But some of the things here, and I don't need to dive too deeply into some of these metrics, I'm sure, but you can see at the bottom, we can see a precision confidence curve. So as we make the model more selective about the bounding boxes that it's accepting, right? The precision is increasing, so it's not confusing so much actual objects for background. And then similarly, right, as we increase our confidence, our recall, the proportion of things that we actually correctly picked up on, right, the model did, is going to decrease, right? So as we're becoming more selective, fairly linearly, right, we're seeing this fall off in recall. F1, again, being sort of this blend of the two, the harmonic mean of precision and recall, it is a really telling curve because it tells you kind of where's the sweet spot for your model performance. And this informs an important operating point, right? Is, if you wanted the highest F1 score, right, the highest blend of precision and recall, you might look at the peak of this curve, and that'll tell you what's a good confidence threshold that I should use to maximize my F1 score. So this would say, somewhere around 0.2 confidence would be the threshold that we'd select, maybe 0.25 or 0.3 maybe. Somewhere around that point would give us, the ideal F1 score. And then last but not least, right, this precision and recall curve kind of describes the constraint that the precision and recall trade-off describes, right? So you can see, as we are increasing our precision, we can see how our recall drops off, and conversely, right, as we are wanting more recall, our precision is going to start to fall off, and you can see this inflection point. Last but not least, I'll just call out, we also have the confusion matrix, which tells us, how did the model's predictions compare against the ground truth ones. So, that's pretty useful to see, right? The model, it predicted something as an object, so 134 times, right? It was indeed an object, right? But 45 times it was actually just background, right? So it picked up on things that weren't actually there, according to this data set. And then 18 times in this data set, right, it predicted something as background, as in it missed something that indeed was an object, right? So this is informative to recall, and this one to precision. All right. It's got a question. So you'll have any custom metrics specific to biodiversity applications, confusion at different taxonomic levels, et cetera. This is something that we do not have currently, and it's something that we're really interested in exploring more. In fact, one of the MBARI internship projects this year, which is going to start in the summer, is focused on this exact question of how can we tailor metrics so that they'll be more informative. So, for example, right, like I was talking about the hierarchical classification, a lot of the metrics around that are things that we're starting to consider that may help us better understand how our models are performing beyond these metrics, which are very much informative, but perhaps don't fit necessarily or can't quite be compared apples to apples to some other environments. Yeah. Okay, so that was stage 2 of the notebook that we just finished. The last one is to run inference. All right. So, if you have your own images or your video that you want to try out, this is the place to do so. You can upload it by clicking on this folder icon here, and then click, upload to session storage. From there, you can drop your own images or a video. Alternatively, if you have some video that's accessible with a URL on the public internet, you can just use that as well in this notebook. Similarly, if you have an image that you want to use from an existing URL, you can just do that as well. So, if you have some things that you want to try out, feel free to upload them now. It might take a second to upload fully. If you do not have any data, we have a selection of 5 different images here that will be downloaded when you run this cell. So we'll click that, and then we'll see these 5 different images, and you can see what they look like here. Hopefully it doesn't take too long. But yeah, so it's just some example images to see what the model can pick up on. From there, right, enter in your source here. Again, this can be a directory of images or video. It can be, you know, a specific image or a video, or it can even be a URL to an image or a video. I haven't quite got the YouTube streaming working from this notebook in particular, but I know that's also an option that you can use with the Ultralytics framework. All right, so once you have that selected, I'm just going to roll with the default images for now. We'll run this cell just to check it out and make sure that it's completely valid. So we can see here there are 5 images that were detected in this data set as an inference source. And then this is the cell that's actually going to be running the inference for us. There's a few relevant parameters that I've identified here, you know, one being that confidence threshold I was talking about before. You know, how selective do you want the model to be? One that has to do with merging different boxes that are in similar locations and have overlap, and that's the intersection over union threshold. You can try playing with that if you have a lot of overlapping things that are getting merged, or you know, conversely, if you have a lot of boxes just drawn over the same instance, you can try setting that threshold a little bit lower. Image size, so you know how large is the image going to be cropped to prior to running the inference, right? And this can help for inference speed, but you know, smaller resolutions, right? But smaller resolutions will also miss this sort of finer grained smaller animals. So you can try, you know, playing around with that setting. Half precision inference on this can speed up inference on a lot of different hardware by using, you know, floating point 16 instead of 32. So you can try that out, see how the results change slightly. And then if you have videos, if you want to stride them, so, you know, not running inference on every single frame in the video, but maybe, you know, you just want it every second on a 30 frame a second video, you could set this to 30, right? And now it just skipped 30 frames at a time. And the last one is agnostic NMS. This has to do with how different boxes with different classes get merged in together. So again, just some things to play around with. There's more documentation on the Ultralytics website if you're curious on that. I will click this button just using our data set, and we can see here, you know, it ran inference pretty fast here across these 5 images. We're getting 4 objects, 13 objects, and some other things. It's going to save the results to inference/predict. So if we wanted to see that output, it's going to be right here. And then this cell will just, you know, visualize that in the notebook for you. So you can click that and we can get a sense of how this model is performing. So you can see it's actually picking up on a lot of the different things in this scene, right? It's correctly drawing boxes on many different things at, you know, a variety of different confidence levels, and you can tune that, right, as needed. So that's all I have for this notebook. Again, you can try like changing this model to maybe 315K, download those weights, right? And then you could scroll back down here and just run this cell again. You can try changing the settings as well, right? And this will use that different model. And you can see the 315K model actually has a lot of classification ability inside of it as well. So we can run this cell again to now visualize the 315K outputs. So it was, you know, identifying that sebastolobus like we were talking about before, keratoisis, and it'll give you, you know, a different sort of set of outputs that you can compare against, right? You know, there's definitely trade-offs, right? This one missed this shrimp here. All right. So that's everything I have for you all. I hope this has been a little bit informative to show you how you can actually get these models running on your own data. You can kind of use this notebook as a starting point, hopefully, to you know, to see how you can run inference. Happy to take any questions, and especially if anybody has like a sort of goal that they have in mind that they're curious to explore. You know, how could the FathomNet models be used to accomplish that? I'd love to chat about that. So yeah.
I think we could probably stay over a couple minutes if anybody does want to hang out and chat a little bit more. But Kevin, would you mind sharing the workshop survey slide?
Oh, yes.
Because as program manager, I have to say these things.
Right.
We have two surveys we would ask you to fill out for us. They really help us make sure we're continuing to improve and monitor our progress. And they're very helpful in allowing us to report to our funders in particular and continue to get funding. So one is more of a demographic survey. You may have seen this before if you've been to one of these before. We reissue this annually, so please fill it out again if you haven't this year. And then the other is more about this workshop in total. And I'll post the links in the chat as well, so you don't have to pull out your phones if you don't want. But yeah, if anybody wants to hang around for another couple minutes and ask any more specific questions, we're all ears. Please feel free to speak up.
Kevin, I was wondering if you guys had looked into or published anything related to like using this as a educational material. I mean, I know you guys have materials that you just showed us that we can educate ourselves, but have you guys done anything in terms of like classroom style like type of material that could be integrated into a college course?
Yeah, we have not. The only thing that you know I'm thinking of right now is actually I took a course last year around data-centric deep learning, and that's taught by Andrew Moss at Stanford, and he was interested in actually picking up some of the data that's in the FathomNet database and using it sort of as an example for how a lot of foundation models do not perform well out of distribution. And you know, that was something that you know we're sort of he's still shaping that out right now, but I don't think we've really curated any classroom oriented material specifically beyond you know what we kind of have existing on the GitHub. But yeah, it's certainly something that we're interested in, right? I mean, that is definitely a focus of the FathomNet program, as Kakani was talking to.
Cool. Thanks.
Yeah. Yeah. Thanks to everybody who's heading out. Thanks for your time.